Right. So in the past, I've used today and this point to check on like where people are in terms of progress in like the course and stuff. But because the exam is coming later than it normally does this semester, just because of the way labs are arranged, and because I'm deciding to do these in lab, I'm going to need to go over. I'm going to instead like tell you where you should be and what you should be expected to do for the next week, so you have as good of a chance to succeed. So in terms of for loops, your exposure to for loops would have been during class, as well as these videos over here with the turtles. You would have had experience with the for loops there, but no more than for blank in range, and then it repeats there. So we don't really talk about modifying things with the for loop, although with the spiral video.
So I've created a new.
With the spiral video, I do have a function that starts outside of the for loop. Sorry, not function, a variable on line 7 that starts outside of the for loop, and then as we go forward, as we go through the for loop, I change it each step of the for loop. So again, remember these are playlists. You're expected to watch all these videos or read the corresponding part in the textbook. One of the two. Okay? One of the two. And then over here, hopefully you've had the chance to learn about the different, lists and strings and how the index notation works. We're going to be talking about basically how we can use the for loop to deal with collections today. That's the plan for today with today's exercise, using the for loop to go over this. And the readings for that are the stuff that will correspond to this are going to correspond to, if I go to modules for a second, for the module 5 stuff, which is this is week 4, module 4, week 5 is going to be module 5. So here is the readings for where I go into detail about the for loop and all the things that we've gone over so far. Okay. Plus a bit about the just a bit about the if statement. See, there's only 3 videos here about the if statement. So if you want to go more depth about the things that we've been talking about and introducing to you in class, you want to watch the chapter 7 videos. The point is that I'm trying to introduce these multiple times as though this is the first time you're learning about it, so that you'll have as much success as possible. Because again, I feel like for loops are really kind of the area that students begin to struggle with. And the other big thing that to cover here is in the videos I do talk about nested loops, and that's probably the hardest part. And we'll see, they won't be the focus, but they'll probably make an appearance on the first exam. So let's go ahead and look at what we're going to do this today. So if we go to module 4, go in here to our class, go to module 4, which will bring me to this other tab that I already had pulled up. We go ahead and click on what I've put from Thursday. I had this scheduled for Tuesday, but honestly, it works right here. And this will be and if you check your textbook, if you instead go there through Runestone, this will be project 6 at the bottom in the project list. Graphing statistics with Kiva. Not graphing statistics, but computing statistics with Kiva. Okay. So Kiva, I assume they're still around. Yep, is an international nonprofit that does microloans. Basically, people need small loans, relatively small, and so this is basically what you do is you donate like $25, and then you're able, at least, and then you're able to direct to what microloan you want to do. So things that are not huge amounts for a lot of people, but you donate these loans, and then since they're loans, they do have to pay them back. But the idea is that once you've donated the money, it will eventually get paid back, which you then loan out to somebody else. It's so you never really get the money back, nor do you make interest. This is a non-profit organization. Okay, but they've been around since 2005. They've done lots of good work, and again, it's one of those many tools that are in the toolbox to try to help alleviate poverty. So the idea here is so that's where today's data is coming from. It's coming from this website Kiva, right? So Kiva, of course, like any website, that's got to keep financial records, will have data. It will have records of the loans it does, and today we're going to be working with some of the data straight from Kiva. Now, it's not a particularly huge amount of data. It's 25. If we were to paste this in Excel, put it in a spreadsheet, we'd have the legend, and then we'd have 25 rows, right? We'd have 25 separate rows of this stuff. Okay, so we have 25 separate loans being discussed. That's not that many. The data set that they extracted this from had 1.4 million rows, but this is a small enough thing that we can actually go through it by eye and say, oh, which one's the biggest? And we can kind of manually check the answers. Okay, but basically we're going to look at some of the kind of very basic tools that we have, and we're going to see how far we can get. We're going to see if we can make our way all the way down to looking at the variance and standard deviation. Don't let the squiggly math symbols scare you. That's again they decided that they don't. A lot of mathematicians decided they have to use Greek letters for everything. So don't let those kind of notations scare you too much. But we'll see if we even can get there in the time we have. Okay. So what we have here is, so what data do we have? We have the ID, which we're not really going to use. Okay. That just simply is the eternal ID that helps, that says, okay, if loans have very similar values, how can I tell the difference between one loan and another? It's basically a way to anonymously identify that ID as a unique thing without having to look at the username, the user, or who lent, or who was it lent to. A loan amount, the amount that was loaned out. The country name, in other words, where's this going to? Azerbaijan, El Salvador, Bolivia, Paraguay, Philippines. Status, they're all funded, so that's not going to really be used. That's one of the columns that we're not going to use either, right? We're not going to use ID, and we're not going to use status. So the loan amount, country name, those are interesting. Time to raise, which I assume is in seconds, but we aren't given a unit, but I assume it's seconds, which basically, I guess, means how long it took for that loan to get funded. And then the number of lenders total means how many people total contributed money. Now, right, we have, for instance, over here, a $200 loan, and we have 3 people who contributed to it. That means that it doesn't mean that everybody contributed, an equal amount. That just means that there were 3 people who donated a grand total of $200. Okay, same over here. This means, in this case, it's very easy to see. One person donated $100, 21 people donated $700 for this loan, and so on and so forth. Okay, so there's all these interesting things here, and the reason we care about this is that as you learn more and more about statistics, you get these nice formulas that you can use to say, oh, okay, is there a correlation between these two values? Is there a correlation between the loan amount, how big the loan is, and the number of people who contribute to it, probably, the time to raise, and the loan amount, or the number of lenders and the time to raise, how strong are those variables correlated? Meaning, if one goes up, is the other one going to go up, or are they inversely correlated? If one goes up, does the other go down, or is there just no correlation whatsoever? Are they completely independent of each other? Right? Do those values have any relationship whatsoever? And that's kind of what we do, again, kind of at the beginning of, here with data science. And he says, historically, we can use these formulas in recommendation systems to find groups of like-minded shoppers that can recommend products to each other. It was the basis of Amazon's recommender system from 1997 to 2000, and I should know this because I was part of the team that wrote that software. Not me talking, the person who wrote the textbook. So even these kind of equations you learn in school can be very useful. And you don't necessarily have to understand it or the math behind it in order to use it, right? Right? You can say, okay, we've got this formula, and if we use it, it gives us this. You can take a black box approach to it, where you put things into it, you don't necessarily know the internals, but you know what it's going to give you, or what kind of tool it's going to work for you. So we've got these this big sheet, but we're not we could plug it into an Excel, but we're not working in Excel. We're working in Python, right? And so what does that mean? It means that we're going to store all these independently as lists of data. Okay, lists of data. Now, here we're taking each column and we're storing it as a list. So we've got 4. Now, all of these are going to be and so this is important to read. To keep your coding easier and cleaner, we will just show you the lists here, but they'll automatically be included for you in later active codes. You can just simply use the list by name and it will be fine. So this is data that exists in all of these. So for instance, we have loan amount, 1250, 500, 1450. 1250, 500, 1450. 1250, 500, 1450, right? So it's the same column, it's just kind of now horizontally laid out, right? Then same thing, country names, Azerbaijan, El Salvador, or Bolivia. We're not just randomly stuffing them in there is the point I'm trying to make. They're in the order. Things in the list appear in the order. Azerbaijan, El Salvador, Bolivia. Now hopefully you watch the videos and understand what I say when I say that the first row, everything in index 0 here corresponds to the first row in the table. And for those of you who haven't had the chance to watch the videos, lists and strings order things by index. Basically, if we say something's at index 0, it's at that one slot, and if it's index 1, it's at this slot, and if it's at index 2, it's this slot. We start counting from 0. So this Azerbaijan is index 0, El Salvador is index 1, Bolivia is index 2, Paraguay would be at index 3. And then we'd have another El Salvador at index 4. Nothing stops us from having repeats, right? Just like you can have repeated words or letters in a string. Okay? So we have this data over here, and we can use it. And what I was saying about you can just use it by name and it will be fine, right? Notice that this has just no actual code in it at the moment, okay? And I can say print country name, and I hit run, and it prints out the country name. It doesn't crash and give me errors. What it does give me is saying that we failed the tests on there. That's okay. So if you haven't seen this yet, the textbook, the reason why creating a textbook doesn't necessarily help you, like creating your own class doesn't necessarily give you the answers to the textbook, is because the questions are all done with a lot of the questions involve unit tests, and if you know how to read those, then you probably didn't need to create the course and look at the code behind it to begin with. It's code to test your code to see if it works. And that doesn't require you to have written code that works yet. So what we're going to do here is we're going to answer some questions. Okay? So first question, so what is the total amount loaned? What is the average loan amount? What's the largest and smallest? Okay? The questions in the list above are the way you would probably think of them when brainstorming or having discussion. Answering them with code often requires more precision in the way the questions are posed. We'll restate these questions and make them more precise. So what is the total amount of money loaned? Compute the total amount of money loaned and store it in the variable loan total. Now the total amount of money loaned, okay, we have this variable called loan amount, which keeps track of how much each loan was, right? The loan amount for each loan. So the total amount of money would be the sum of all that, right? Now here's the thing. This is very specific. It's saying, so it says, take that amount and store it in the loan variable. So I could just simply, now me knowing Python, I could say print sum loan underscore amount. And the sum is one of those nice built-in keywords. Now, this isn't going to work in a second, but I mean, like, this would normally work. Okay? It says I need a note. So first off, it says, okay, let me go ahead and break it up into 2 lines then, right? It wants me to store it in the variable called loan total. Loan underscore total is equal to sum loan amount, print loan underscore total. Okay, and it gives me the correct answer. It says, hey, you need to use, we created a loan total variable. We printed out the amount that it is, which is 16,575. We didn't actually need to print it out, actually, for it to test. It just looked in the variable to see if it was fine. You may not use sum. So here, there's a lot of functions that help in Python, like min, max, sum. Those are nice. These are very nice functions to have. But here we want to learn how to write them ourselves. Okay? So here we're going to use the accumulator pattern instead to do what we need to do. Now, the way that works is that, again, we have an accumulator, something that we add things to. Sometimes we subtract things or multiply things into it, but the vast majority of times we're adding things to this. Loan total is equal to 0, and then we have a for loop that says, hey, let's go ahead and actually, I'll write this down so that you can have a go at it. For each loan in loan amount, and then what do you want to do for each of those? Add, let's see, increase loan underscore total by that loan's value. Yep, for each loan in loan amount, underscore amount, in the list loan amount, increase loan total by that specific loan's total, right? So so we have so we'll need to write a for loop for every loan in the loan amount, increase loan total by that specific loan's value, right? So go ahead and take a few minutes to this. This shouldn't take too long if you've been following along with the accumulator pattern in the previous lectures. And if you're still having trouble with it, no worries. Watch the videos for Module 5. For those of you having trouble with the first step, writing that for loop, for each loan could be written like this: call it loan in loan amount. All you need to do is that. No need to use range there. Range is when you want to create a specific range of numbers. If you want to iterate over a collection, it's that simple. And then now we can do this part. So if you haven't done that yet. All right, what do we put, so what do we put in here then? Anyone? Everybody's so shy today. Yes. Exactly. Loan total plus equals loan. So for everything in loan amount, we increase loan total by that amount. And let's see, it says you may not use sum. Where is it getting the sum from? You may not use, oh, because, I know why it's telling me I can't use sum, because code is dumb sometimes. What it's doing is that it's scanning my code for the string SUM. And it sees it in the comment. So it's like, aha, you're using sum, you sneaky person. So there you go. I removed that comment now and it's fine. Again, with code, it's an evil genie, right? It's going to do exactly what it says. All right, part 2, compute the average amount of money loaned and stored in the variable loan average. So this is actually just an extension of what we did previous. Why? Because the average, what is an average? An average is equal to the total amount divided by the number of number of things added together, right? The total amount plus the number of things you added, right? That's our average. Now, we've got the above amount. Well, how much is the total amount? It's loan total. So I'm just going to steal that from up here, right? So the average is equal to the total amount divided by the number of things that were added together. Loan total for loan in loan amount, loan total plus equals loan. Now, I told you beforehand it was 25, but suppose I didn't tell you that. How would we know how many things we added together? Yes?
Take the length of the...
Exactly. We would use the len function. So that's one of two ways. That's the easy way and the way you should do it. The other way is that if you forget about length, well, for each one of we could have a second item being accumulated here, and we could add 1 to it each time that we add something. It's an over-the-top way to do something, but for the most part, it's fairly straightforward to calculate the average, which is we take the total, so loan underscore total, not loan total, loan average, that's the answer we're looking for, is loan underscore total, right? Divide by length of loan underscore amount. That's how many things we have. And here it says you can't use sum, use the accumulated pattern to add up all the loans, which we did. So we added up all the number of loans. So the average amount, so now we can say that for all those loans that we've made, each of the 25 loans on average was 663. Now this probably isn't the average amount of loans on Kiva, because we're just looking at 25 of them. The more loans, if the more loans that we had, the more accurate our estimation of the average loan amount would be. Or not estimation, but calculation. We're not estimating here, we're calculating it. Based on the data we have, it's 663. But we know that that data is incomplete. Okay. Now, this one is where it starts getting a bit, maybe. Store the amount of the minimum loan in min loan and the amount of the maximum loan in max loan. Then store the name of the country that received the largest loan in max loan and the smallest loan in min country. Let's go and actually put that go back to the plain English question. What is the largest and smallest loan, and what country got the largest / smallest loan? Which country? Which country got the largest or smallest loan? Okay, so that's combining those two questions. Which is the smallest? What's the smallest loan? What's the largest loan? Who made the which country received the smallest loan? Which one received the biggest loan? So now once again here we have the ability to use two built-in functions that this problem does not like us using. If I want to find out what the smallest thing in a list is, I could do this. Print loan underscore amount And what I'd do, all I'd have to do is surround that loan amount with the min function. It's built into Python, which is this very, very, very flexible thing. First off, it can take in a list, and it will tell me what the smallest thing of a list is. Let's see, error, min loan is not defined. Okay, min underscore loan equals 0. I didn't even want to run because I didn't define that variable. And it wants me to, it's not going to run unless I actually define those variables. Bleh. Max loan is equal to 0. Doesn't matter. And then min country and max country. So it just wants me to define those variables before it, because otherwise it can't test it without crashing. So don't worry about that. Min country is equal to bleh. Max country is equal to bleh. And so now it's going to say, use the min function. It wants me to figure it out using the min function and max function. Okay, I could have sworn from when I've done it all the last times it wants me to use those functions, those functions there. So here we've got the min function. We go and we can figure out what the smallest thing is by using min. Okay, so min loan is equal to minimum loan amount. And max loan, we can figure out by doing max loan underscore amount. They each find the biggest thing. Right? It does exactly what you expect. Find the minimum, find the maximum. Let's go ahead and see how this works in action just for a second using idle. Right? I'm going to create a list called L. Right? So L is equal to 1. It's equal to 1, 2, 3, 4, 5. The minimum thing in L is going to be 1, and it's not just saying that because 1 is the first item. L is equal to 5, 2, 1, 3, 6, 4. Min L, still going to say 1 because 1's the smallest thing in there. Max of L is 6. And we could do this to, you can actually throw, if you want, you can like throw in multiple things in here, multiple arguments in it, and it will find the biggest of those arguments. Lastly, let me see if this works. I think it does because all it takes is an iterable. Max of banana is n. Why? Well, yep, it's the farthest letter of the alphabet in the string. It's the farthest character. Whereas min, because that comes first, is going to have a lower value. Lowercase a actually corresponds to a value of 97, B a value of 98, C a value of 99. The only reason you should have this memorized is if you give an assignment out that deals with encryption and thus you've had to write this multiple times. In other words, you should probably never have to remember that A and 97 are the same thing. So don't worry about that bit. But the point being is that since they're numbers, that's how it compares to know what letters come before numbers. What letters come first. But yes, it figures out things alphabetically when you're dealing with strings. Okay, so we've got our minimum loan amount, we've got our max loan amount. Then store the name of the country that received the largest loan in max country. Now, we can't find that out just by using loan amount, right? If we go back up, sorry to make the people who have to watch this again dizzy, we have four things. We have loan amount, country name, time to raise, and num lenders total. And the thing that you got to note in order to make the jump for how to figure this out is that if you have to go back to the beginning where I said, that this value and this value correspond to the same one. So the thing at index 0 over here matches this index 0, matches this index 0, matches this index 0. So 100 is our smallest loan. Index 0, index 1, index 2, index 3, index 4, index 5. So we know this corresponds to index 0, index 1, index 2, index 3, index 4, index 5, which is the Philippines. Okay? So we know that corresponds because they're going to be at the same index, right? Just how that's the same in the same way that these are going to be on the same row. Make sense? They're going to be in the same index because they're on the same row. So now I could just simply say Philippines, right? And cheat, but that's probably not what I want to do. Instead, what we need to do is we should use the is that we should make this work for any kind of data set, right? Instead, what we should do is we should, make it so the computer can figure it out. And what we have here, again, is I'm going to go back to here. I'm going to show you a new L. L is equal to, actually, I'll do a list. Word, yeah. Let's go to, actually, yeah, we'll use banana as our word. It's actually a great word for this, banana. If you've watched my videos, I use banana a lot. Okay, so word banana. And both lists, I believe that this should have an index function. Dot index. Yes, it does. So this is the tool we'll be using here. And it works the same on strings as it does on lists. So you can take this concept and apply it to the list that we're going to be working with. Banana A and word.index n. What this index does is that it returns the first index at which this thing occurs. It's asking, okay, for word, what is the first index that B occurs in? What is the first index that A occurs in? And this is index 0, index 1, index 2. So it returns B because B only occurs once here, A because A first occurs at index 1, and N because it occurs at index 2. Make sense? So what that means is that we can go back here, we can ask, hey, loan amount, what index does 100 occur at? And it will tell us index 5. And then we can do the same thing for our larger value. Everybody follow how that works? So we go and we say, okay, min country. So loan. So, however, it's probably not so in other words, we need a couple of steps in between here and there. So let's go ahead and create something called min index is equal to loan amount dot index of the min loan. So it's asking loan amount, hey, what's the index, what's the first place that this number occurs? See if you can go from there to here. And as a reminder, the country names are going to be in here, country name. So you'll need something that's like this. It starts like that. So I've almost given you all of it, so see where you can go. Let's go ahead and in fact do that. So min index, that's really all we needed here to pass it. And over here, we do the same thing, but we say we could do max index. And the reason I'd want to do that is because I split it up into multiple lines, by the way, because otherwise it looks like this. Country name, let's see, loan underscore amount, loan amount dot index of max loan, and this is actually a very good example of why you want to split things up, because if you try to do it all in one line, you can, it just gets awful, right? It would be, you could do it all in one line, like each of these in all one line, like by doing this instead. And that just looks horrible. Don't do that. Right? That's, readability is king here. So, right, these two lines together is a lot easier to read and a lot easier to debug than this single line. Make sense? So I would do this as opposed to doing that. So what we do here is we get the we get the index of the smallest loan stored here and ask country name, hey, what happens to be stored at this particular index, 5? It says, oh, the Philippines. And so that's our answer. Okay. So let's go ahead and look at this other one. This one's asking, what is the average number of lenders each loan receives, right? If we go back up, we can actually check that word. Yeah, what is and that's not the variance. That's much later. Okay. What is the average number of loans? Yeah, the average number of lenders per loan and stored in average lenders. So in other words, it's asking you, what is the average for this? The number of lenders total. So go ahead and try that one yourself. We had kind of a palate cleanser in between that, asking a different question, but this should be but see if you can do it without referencing back to the first question. Okay? So, and I'll make sure I give you that one thing so you don't need to reference back, which is that you want to use work with variable num1 total. You don't need to copy that down. You just need, I'm just putting this down over here so that you have, for reference, num lenders total. You want to calculate the average number of lenders there were. Try to do it without referencing back to the code we did previously. So let's do this one. So same kind of idea here. We want to compute the average number of lenders. Okay, so let's see, what do we need here? Average lenders is equal to 0. We'll start with that just to begin with, just so I can see. Yep, we don't need them. Very similar to a earlier problem, it says. Okay, so what we need is, right, we need a total. Num loans is equal to length of num lenders underscore total, right? Why am I doing that? Because what we have is here is that we're working over here, and we want the average of this. The average is the sum of all the things in here divided by the number of things there are. We'll do the sum of all the things and put that in total, and we'll divide by the number of loans. If you were having an issue with getting it to run, it may be because if you declare that as sum, the issue might be that the code in the background might have been using sum, and you just said that sum is a number instead of a function, and it got confused. So not necessarily your fault, but this is part of the reason why I use total, because number is already a sum is already a function that I don't want to, overwrite. So total is equal to 0. Num loans is equal to that amount for value in num lenders underscore total num underscore loans plus equals value. And now finally we get our average underscore lenders is equal to the total divided by the number of loans. Let's see, average lenders, what's going on? I had 0, num loans. What mistake did I make? Yes.
Total
Exactly. I was kind of on autopilot. This is what happens when you talk and type at the same time. But sometimes you write down the wrong, you mean one variable and you write down the other. So total is equal to 0, num loans. For every loan, increase the total by that amount. By the number of people who lent. So on average, 18 and a quarter of a person were involved in each loan. All right, another kind of simple one over here to illustrate the point of here. We've got this variable called Philippines count. It's equal to 0. And I bet you it's trying to say, hey, you can use the count function here. You should use a list method to count. So count is pretty cool. Again, let's go back here to banana. Word.count. And again, Python operates on the principle of least surprise. Count of A is 3. And count of N would also be 3. Oh, sorry, 2. There's 2. And then count of B would be 1, because banana has 3 A's, 2 N's, and 1 B. So, count counts the number of things that we have in here. So it's asking how many loans have been made to the Philippines. And so that's fair. This is a one-liner. We can find out how many loans have been made to the Philippines by saying, okay, we've got this variable called country name. Okay, and that's the list of all the names of all the countries that have been loaned to. And we can count the number of times that the Philippines got loaned to. Philippines. And that should be 7, it says. And there you go. It will automatically count for us. Now, what if we weren't allowed to use this variable, this function over here? What if we weren't allowed to do that? If that was the case, what I would do is I would say, I'd still do the same thing over here. Philippines count is equal to 0. Instead, though, and I'd say for country in country name. Actually, let's just simply say for name in country name. For name in country name. And now here's why it's saying to use the count variable, because I haven't introduced you to if statements yet. But they look like this. This is as good as time to any, just to kind of give you your first exposure. And it works fairly straightforward. If name equals, whoops, and then we'll take this, the Philippines. If the name is equal to Philippines, Philippines underscore count plus equals 1. And that would, so what does this do? Well, we iterate through every name and country name, right? And if the name is equal to Philippines, then we increment it, right? This variable, this over here is called an if statement. If statements take a Boolean value. Boolean values are named after a mathematician named George Boole. If you probably learned about this in 1166, if you take 1166. But this, and basically what Booleans have only a value of true or false, okay? True or false. So either things are equal or they're not equal here. And in fact, we can go ahead and print out that what we see here. Name, and then we can take this print statement and copy it. Name is equal to Philippines. And we can print those two things out. Azerbaijan is not the Philippines. El Salvador is not the Philippines. Bolivia is not the Philippines. The Philippines is the Philippines. True, right? Philippines, right? We see that this is the we can see that this is the statement over here. Name equals Philippines. Again, the equal sign over here, what is the difference between equals assignment versus double equals? Two equals says, hey, give me a Boolean back. Check if these two things are equal. That's what the double equals is for seeing are two things the same. And it's fairly, and what do we mean by the same? The most unsurprising thing in general. For everything built into Python, that should be the most unsurprising thing. Two numbers are the same if they have the same value, right? Two strings are the same if they have the same spelling. And when I do say spelling, I mean, what Python cares about spelling, which is case sensitivity, right? Now it's all falses because I made that lowercase, right? But again, we haven't, this is for next week. Next week is the if statements, but they're not, as you can see here, they're not particularly complicated. You can do things like, hey, if x is less than x is less than 7 or something like that. But again, for right now, for doing this, this is fine. A lot of, in most languages, they'll have something like this already built in, the count function. Okay. All right. For each country name, print a line that shows the name of the country and the number of loads made in that country, like this, Guatemala 1. So here are the unique countries. Oof. So, I'm already like kind of just going over here to now, here's the issue for me. I'm already kind of going and saying, aha, I know what the perfect tool is, a dictionary. And so we should use a dictionary to do a count of all these things. But we haven't learned dictionaries yet. They're like at the end of the semester. And at the end of 2168, which is the third computer science class. So that's obviously not the tool we need here. Just because you have a complex and powerful tool doesn't necessarily mean it's the best thing to use. Here, we want a line that shows the name of the country and then the number of loans made to that country. So, and that's actually not too hard. I don't need those tools. I'm thinking, okay, do I have to have a nested for loop? Do I need to? No, right? We just need to use what we've learned. It's very easy for even me to overcomplicate these problems. But our solution here is fairly straightforward. For each country, how would I know how many loans have been made to Guatemala? I would look at country name and see, okay, Guatemala appears once and no other times. What about Jordan? Jordan once. What about Kenya? I'm going to say Kenya because I know I saw more than one Kenya. One Kenya. Two Kenya. Three Kenya. So 3 loans have been made for Kenya. I'd go and count how many are there in the country name to find out how many. So that's what I should do here. For each of these unique countries, come on, type correctly. For each country, print, indent that a bit, print the name and the count of times it appeared in country underscore name. Right? So go ahead and take a swing at that again. Okay, I was worried that I had this pause for a while, but I haven't. I'm going to pause it now. Okay, so for this one, for each country. So let's go for every country and country name, for each, let's call it name again in country underscore name, print, scroll down so that giant arrow's out of the way, print name, comma, and then the count of the number of times that appeared in country name. Again, it's very easy to overthink these things, but country name dot count of the name. And then we should get, whoop, looks like I failed, so use accumulator to add up all the loans. Azerbaijan 3. Yes? Sorry? Country name dot-
Instead of country name, it should be unique countries.
The unique? Oh, yes, unique countries. That's right. Went over the wrong one. Unique countries. There we go. So unique for name and unique countries. Print name, country.name, country name dot count name. So we count the number of times it appears in here for each of the ones in here. All right. So let's go ahead and I think, let's see. Now, a lot of these, let's see what time it is. 3:06. So I'll do this last one and then I think I will start alleviating some stress by showing you a bit of what the practice exam in the past has looked like, which will be a good indication of what the exam will look like. So P average. P average is equal to 0. So the index positions for the Philippines are these values, which I'll just simply call P index is equal to this. So here, what this one is trying to do is say, hey, calculate the number of the average loan amount that was made for the Philippines. So it says, here's all the locations that the Philippines are at. Store your result in P average. So same kind of idea here. Whenever you see, hey, compute the average, doesn't matter how complicated the question is. The total is equal to 0, and the num things that we're dividing by, the number of things we're adding together, is equal to 0. So in this case, it should be num loans to P? Sure, why not? Big variable name, but whatever. Total is equal to this, num loans made to P. So we know that there's been 7, but again, rather than automatically program, rather than just hard code that in case this would work on other pieces of data, we could say length of this. So total is equal to 0 for, not for blank, but for. And so this one's a bit more complicated because what we're going to need to do is that we're going to go from here, which is these indexes, and we're going to get each loan from that index. So for index in P index, loan is equal to loan underscore amount, all right, at index. So we ask, hey, so given this first index, can you give me the loan at 5, then the loan at 6, then the loan at index 7, at index 9, and then the one at index 11. And then what we need to do with that is total plus equals that amount. Now I could break this up into one line rather than 2, but I like the way I wrote it. Again, readability is king here. And that actually, I shouldn't need anything else, right? I need a accumulator, and what it says, store your result in P average. So now that we have that amount, we need to calculate the P average. The average for the Philippines, which would be average, again, is super easy to compute, which is just simply what we've already computed, which is the total divided by this giant variable name I created, num loans to P. And so that's 253.5 and a bit dollars. All right. So let's see here. So if you want to get some more practice, this is actually going to be very good. But with the amount of time we have remaining, I think it's better to kind of show you, okay, what should I have you look at so that you can, to incentivize, to tell you, hey, what's important for you to know for the exam? Because that's always at the top of minds for people taking a 1,000 level class, especially if it's a new subject. What is the exam going to look like? Where should I go for that? So let me go to teaching, show and explore. This should be an intro, and let's see, exam one practice. So I've done this one in the past. So I've used this many, many times in the past. Okay, and I'll be revamping this one based off of stuff. But we get, but here's a couple of so first off, you'll have a few basic questions like this one. Computer science is the study of computers, true or false? Who is Ada Lovelace and why is she an important figure? So stuff from couple questions about very first lecture. You'll get questions like you've had to do in the exam. I give you 10 here. You'll probably get 5 on the actual exam. Remember, you will not need a calculator to do any of these. If it looks like it needs a calculator, it's because it's a dirty, rotten trick. Okay? You should not need a calculator to do anything you won't need to. Right? You do not need a calculator to solve this one. Okay? So, some of these also are just simply making sure that you know how to diagram things correctly. What does that mean? What are the values of X, Y, and Z after the following statements? Understand, okay, how do things update? These are some Boolean statements. Again, they'll be there whether or not you've got this in the exam. Sorry, whether or not they're going to be in the exam. For these kind of questions, I would highly recommend, and again, I've still got to write the practice exam for you, but for these kind of questions that are logical, use a pencil and, cross off whether or not, and simplify it. 3 or 2, cross that out. Sorry, 3 equals 2, cross that out. That's a false, right? Some questions about slice. What are some questions you might, what are questions that you might actually need to, know? That definitely. Draw the result of the turtle program below. So here's a turtle, and then you'll learn what functions are for in Lab 5 in the next coming week. But basically, draw this code for a step in range length. Length in this case would be 5. So in other words, do this block of code 5 times. Okay, and then now I've changed the code. I said to add this in. What does that do? Okay, and don't worry, you will get this. I just have to adjust it. Same thing over here. Draw the result of the turtle program below. You can draw a dot to represent a stamp. Stamps are useful when I don't want you to draw a bunch of lines going over everything, So stamps are useful for you to that. Very common thing. You should know how to draw a square, right? And then using the draw square function, write a turtle program that will draw the shape below. You can create more functions if you wish. What are functions again? Right, those are just simply the ability to add verbs. We will be going into more detail on that, I'm sure, on Tuesday. But here, and again, I try to be as easy as I can, as explicit as I can with this. We can see that the turtle ended up here. And I also mentioned that the turtle drew 4 squares. He didn't draw like 1 square and then another 2 squares over here. And, it's not one of those, how many squares can you see? This is 4 squares, not like, not like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's not one of those kind of questions. It's 4 squares that he drew. Occasionally, I'll also say, hey, notice that I say in the practice exam, this one's worth 10 points. And then I'll say, hey, this one's worth 0 points because if you're timing yourself to see how well you can do, that's a way of saying skip this question, come back to it later for additional practice, right? same square, use, same problem, use it to draw this. So as far as other, so that's the kind of extent for writing code. I give you something and I tell you to like draw it. This one also says print threes, which prints out all the positive integers less than limit that are divisible by 3. So you'll learn how to do that with the if statement again in the upcoming stuff. Again, the exam is not going to be happening until not next week, but on the 23rd or the 26th, depending on your lab, right? So got plenty of time to do that. And speaking of your lab, right? Let's go ahead and just take a quick look at it, but your TAs should be giving you a nice thorough introduction to it. Okay, but in case Murphy's Law does occur, let's take a very quick look at it. Lab 4 and 5, I will extend that due date because definitely should have a longer time to work on it. Okay. Lab 4 and 5, because this is the lab for both 4 and 5. All right. So here I do talk about how to create functions in Python. Writing functions is a part of this lab that you'll need to do. Okay, and I show how to do that. And also different ways you can manipulate the print function to do different kinds of print statements. Problem 1. So this is split up into 3 parts. First part is printing with text. The first question is basically printing out the 99 bottles of beer on the wall song. This is a very common first semester question. Replace with the beverage of your choice if you don't want beer here, so it doesn't really matter. The point is the 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 being printed out in the text. Okay, next is creating a multiplication table. And then function which, given an integer n, uses a for loop to print out the sum of all the numbers squared. So for instance, you should ask the user for a number. If they say 5, I want you to simply print out 55. You don't need to print out the equation, but you want to print out 55 if you put in 5. Why? Because 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared is equal to 55. So I would highly recommend putting all these 3 questions into one file. And then the next part, this should all be in one file. I don't want to really see it in multiple files, right? So each of these problems will basically build off what we've done for turtles to build more complicated figures. First is the stairs problem. Part 1, draw a square. Pass. I don't want to see pass in your code here. What is pass? Pass is just simply so you can copy and paste it into your code, and it's not going to, and the function header that I declare here is not going to upset the rest of the program. Basically, pass means fill in later. Okay, that's what pass means. It means fill this in later. Okay, draw square. Then the idea here is you can use draw square in the next problem to draw a row of squares. And then you can use that to draw a grid. And then finally draw stairs. Okay, I'll most likely ask you to just simply show me that, because if you can show me that, I can look at the code and make sure that it will work for all the other ones. And finally, the last 2 problems, something very similar to what we've done before. Given 2 variables, num sides and the side length, give me an n-sided polygon. We did that. We've done this twice already. Once in class and once for homework in lab 3. Now we're just doing the side length. Hold on. Yep. And then super spiral. It's like, wait a sec, how'd you get from here to here? It's actually not that bad. I actually include the comments on how you do that. And then this is my example output. It does not have to be your example output, but this is my example of Bob creating 35 6-sided shapes, each of size 100, each with a side length of 100. So, And then there's also extra credit here. Each extra credit is worth 5 points. So, yes. I can hit the share code button on all of them, sure. Okay, so let's go ahead and stop recording.